Okay, hello, ladies and gentlemen. This is Mr. Rosales. Sorry I couldn't be there fourth hour or sixth hour. I had to go to a training in Emporia. You should have finished your quiz for 1-5. Make sure that gets in the basket before you leave. And today we're going to do 1.6 called deductive reasoning. There'll be times where you can pause the video and work on some problems. And then if you're watching this on your own computer, you can pause it and play it as you wish. If you're watching it in the class, if the link works, then you guys will just watch it as a class. Okay, so we're doing deductive reasoning. Last class, we talked about conditional statements. We said if then sentences. For example, if today is Thursday, then it is a weekday. Every conditional is either true or false. When you hear it, you're going to decide true or false. And that's what you guys had your quiz on. We're going to add to that today. So we're going to start up with a warm up. It says there's a deck of cards numbered 1 through 15, and there's 4 different shapes. So you could have a card with a triangle, you could have a card with a circle, a card with a square, a card with a pentagon, but there are 60 of those cards 1 through 15. So what happened was a teacher 7, the last card is not turned over. All of those cards have triangles on them. The last card, we don't know what number it's going to be or what shape it's going to be. She tells her class that all of the cards she selected have the same shape, and she asks them to draw a conclusion about the 5th card. Here's what 2 answers were from a couple of students. Chin said, I think the 5th card is going to be the number 11. Carolina said, I think the 5th card has a circle. Take a minute and decide, how did Chin come up with the number 11? Chin is looking at the numbers 2, 3, 5, 7, and he's realizing, oh, these are prime numbers. Prime numbers, the only way to get it is multiplying by 1. The only way to get 2 is 2 times 1. 3 times 1 is 3, and so on. 5 is the next prime, 7 is the next prime. Well, the next prime number is 11. So what he guessed, we would say that's logical. It's the next prime number. And he is just picking this because it's from his observations, right? So when you notice a pattern, like we've been talking about this unit, logic says follow the pattern. So it's not a bad guess. Maybe he'll be correct, maybe not. I can understand why he said 11. Carolina says, oh, the 5th card has a circle. Does she know that for sure? No. Have we seen the card? No. So we could just say right here she's guessing. This is totally random. She doesn't know. So we could say Chin was logical, connecting the prime numbers together. And we can just say Carolina guessed. There's nothing wrong with guessing. Guessing is totally fine at times, but if we can try to be logical about what we say and what we pick, that could probably lead us down a better path. Sometimes you just don't know and you have to guess, but that shouldn't be our first thing to think about is, well, let me just guess. So that leads us to B. What other possibilities are there for the 5th card? What could the teacher say to narrow down the possibilities? Well, think about it by shape. How many square cards are left? Well, we weren't dealt any square cards, were we? So there are 15 cards that remain for that. Let's see, triangle cards. Well, we already got 4 triangle cards. So that means there are 11 cards left. Circle, we didn't get any. 15. Let's see, pentagon, we didn't get any. 15. Those are all the shapes, right? And then, yeah, any numbers between 1 and 15 for square, circle, pentagon. And we know what numbers for triangles would be left. It would have to be the numbers that were prime that we picked. But yeah, those are all the card options we have left. And connecting that back to Carolina, when she says, "Oh, I think it's going to be a circle," honestly, we could say, "Hey, well, there's 15 circle cards. Um, out of 60 total cards, there's probably a good shot that she should get a circle." We could find out that percentage like we did last class, and we could come up with a decimal if we wanted to. I'm not saying we're going to right now, but that's just tying logic. And you could find the percentage that's left if you wanted to. And she could have said, "Oh, well, I think circles are 28% of all the cards, and maybe that's why we'll get a circle." So she could have done something like that. So if you can justify what you're selecting, that'd be good. Okay, so deductive reasoning. We talked about this table last class. Deductive reasoning is where you have givens and some known information that's going to help you come up with a conclusion. If you weren't here last class, we said that P, the letter P, is called a hypotenuse. I'm sorry, not a hypotenuse, hypothesis. And Q is called the conclusion. Last class, we drew these symbols. P implies Q. That's how you read that. It says if P, the arrow means then Q. So if P, then Q. This is called the conditional. And it's like those sentences that we were talking about in the beginning. If today is Thursday, then it is a weekday, right? I'm recording this on Thursday, by the way. So that's why I keep saying Thursday instead of Friday. But it's an if-then sentence, right? If I am a sophomore, then I am in high school, right? It's an if-then. And we have this chart where either the hypothesis could be true, conclusion could be true. That would make the conditional true. And you see all the other ways I could arrange things to be true or false. Now, with that table that we're looking, I could give you something like this. So how do you read this table? It says TTT. If it's Friday, comma, then it's a weekday. I'm just going to abbreviate for space. But today's Friday, right? You're watching this on Friday. That's true. So the hypothesis is true. Then it is a weekday. That's true as well, right? So if both of these are true, we can look at the entire sentence and say that whole sentence is true. That's how you use this chart. Now, when you see F, F means not, okay? So F means the opposite of what we have. So write down the true hypothesis. We would say again, with no change, if today's Friday, that's still true, right? Today's Friday. And then they say write down the not version of the sentence. We would say then it's not a weekday. So let's think about that. If it is Friday, it's not a weekday. That last part is false. So we know Friday is a weekday. So when it's true in the beginning and then false at the end, the entire sentence is going to be false. So if we read it, if today's Friday, then it is not a weekday. That's false, right? The whole thing's false. So that's how this table works. You could come up with the last two rows on your own, but just wanted to realize you're going to see tables in the future, and we just have to know how to manipulate the tables. Okay, so example one, they say we've got that table. If a hypothesis is true and the conditional is true, what should we read in our table? So hypothesis is true, the conditional is true. Well, look at the table above. What is Q all by itself have to be? So scan for that. Where was the hypothesis true and the conditional true? The answer has to be true, right? That's the very first line. Yeah. If we just hunt for it, I could give you another one. What if I said false for hypothesis, false for conclusion? What's the conditional? Well, if we look at the table, oh, I got false here, I got false here. T must be my answer, right? So those are going to be questions like that. I'll give you a table and ask you about two parts of the table. You will tell me about the third part of the table. So hopefully not too bad. So we can say the conclusion will be true on the table. All right, next, we're going to talk about detachment. So this is the law of detachment. It is where you have a conditional statement and its hypothesis are both true. If that is true, the conclusions will be true. So we're going to use an example, and it's going to teach us about what it is actually doing. So it says, if Alicia scores 85 or greater on her test, then she will earn an A as her final grade. So that right there is your P implies Q, right? So assume all of this is true, right? That's just a true fact. The teacher told Alicia this. If you score 85 or higher, then you get an A. Well, now she goes to take the test. She got an 89. What can you conclude logically? Did she meet the goal of 85 or higher? Yes. So, what's her final grade? She earns an A. So, if you take the test and score higher than 85, comma, then you get an A. You score 89. So then we get to say Q, the conclusion is I get an A. And we call that detachment. If I give you rules to the game and you follow the rules, then what conclusions can be made? And we can do this a lot. Like, if you drive over 60 miles an hour, then you get a ticket. You were driving 80 miles an hour. You would say, I get a ticket. Or I could do that exact same sentence. If you were driving over 60 miles an hour, then you get a ticket. You were driving 30 miles an hour. What can you say? Hopefully, you would say, I don't get a ticket, right? You did not break the rules. So, we're going to give you a situation and something that happens within that situation. Can you tell me how it ends? That's what detachment is. Next, on number 3, we have, actually, you know what? Skip number 3. We don't need that one right now. Oh, that's not going to be on the test. So we're going to do the other stuff next. And it's called syllogism. The law of syllogism is we have a conditional, and we call this the first conditional. We have another conditional. We'll call this the second conditional. What's going to happen is we're going to look for repeating information. We're going to ignore that information. And that is going to create a third conditional. This is going to be our third conditional. So we're going to have 3 sentences that are if then. We're going to look for repeated info, and it's going to create something entirely new. So check out example 4. It says, if Kenji plays the trumpet, then he plays a brass instrument. If he plays a brass instrument, then he is a member of the marching band. So we're going to look at each of those sentences one by one. So the first conditional is right here. If you play trumpet, then you play a brass instrument. That's the first conditional. The second conditional, if you play a brass instrument, then you are in marching band. So first conditional, if you play the trumpet, then you are play a brass instrument. If you play a brass instrument, then you are in the marching band. That's our second conditional. So all we have to do is look for things that repeat. Specifically, we want to look for something at the end of the sentence that repeats. That is the beginning of the next sentence. So look, you play a brass instrument, you play a brass instrument. What syllogism says is it completely ignore that. Ignore what repeats. Whatever's left, you can make a logical connection. If you play trumpet, comma, then you are in the marching band. Okay. And when you think you have it, unpause it and see. Okay, on example 5, here should be the conclusion. So it says if A, B, and C are collinear and B is between the points A and C, then ray BA and ray BC are opposite rays. If ray BA and ray BC are opposite rays, then AB plus BC equals AC. What can you conclude? Here's what you can conclude. We can conclude, after we get rid of what repeats, if A, B, and C are collinear, and B is between A and B. Actually, I lied. That should say A and C. Let's get rid of what repeats. Whatever's left is our answer. That's all we're doing. That is syllogism. You guys try example 6. We are not doing example 7. We will not be seeing anything like that on the quiz or the test. But try example 6 when you're ready. I'll check it out. Okay. If you're climbing a mountain at an altitude of 28,500 feet or higher, then you are on the tallest mountain above sea level. If you are climbing the tallest mountain above sea level, then you're on Mount Everest. So, we're going to start with this. They say, hey, you're at an altitude that is a height from the ground. You're at 29,000 feet. That's almost as high as an airplane goes in the sky. So just to give you an idea. You're at 29,000 feet. Well, guess what? Look, right here. If you are at 28,500 feet or higher, then you are on the tallest mountain. So that's detachment. Detachment means, hey, if I know a certain fact, then I can apply it. So we could say something like, since we are at 29,000 feet, we can conclude we are on the tallest mountain above sea level. Right? They gave us the beginning of the sentence, and we just used the end of the sentence. That's detachment. Now, syllogism says, hey, if you see things that repeat, ignore them. So look right there. I see those two things repeat. It's at the beginning of one sentence. It's at the end of one sentence. And we can say, we are at 29,000 feet. So we conclude we are on Mount Everest. That's it, y'all. So that is all we're doing. You have the rest of the time to work on the practice. Get all of those done. I'll put the answers up on Teams if you want to double check those. I will not be here for advocacy because I'm gone all day. So please don't come to advocacy in my class. Go to your normal advocacy. Go see a different teacher. And if you have any questions, feel free to take a picture, email me over the weekend, or check Teams if you want to see that work. Have a great weekend, and I'll see you guys next week.